John McGill is a firefighter with the Slippery Rock Volunteer Fire Company and Rescue Team. 17 years ago, he and a fellow firefighter were on their way to a call when the GMC Brigadier tanker they were riding in rolled over and crashed. The driver suffered a broken shoulder, but John had more permanent injuries.
We're going out the road and we lost control of the truck and it started to go broadside and we hit a telephone pole, and next thing I remember, we're on the side. From the accident, the injuries I received was a C6 spinal cord injury and facial cuts. And then I'm paralyzed from the chest down, and I have pretty good use of my arms and limited use of my hands, and I think I do pretty well for what I thought I was going to end up with.
There's a sad irony to John's story. The crash that left him paralyzed occurred just 5 days before his first wedding anniversary. Here's the thing you ought to know. John's rollover crash, like all rollovers, could have been prevented. And in this presentation, we'll show you how. Nationwide, the number of rollovers involving emergency vehicles has skyrocketed in the last few years. A large majority of those accidents were single vehicle crashes. So what's going on? Well, according to NIOSH investigations and a USFA white paper report on the subject, the cause of most rollovers is driver error. That means you. There may be many factors that contribute to a rollover crash. Wet roads, poor visibility, too many distracting voices on the radio. But it all comes down to you. Now, here are 3 key things to keep in mind. Excessive relative speed is a common reason rollovers occur. Many fatalities and serious injuries can be avoided if the occupants are wearing their seatbelts. Neither John nor the driver of the tanker had their seatbelts on. Both fire and EMS vehicles are commonly involved in rollover crashes, in particular tankers, pumper tankers, ambulances, and aerial apparatus. In this program, we're going to take all the components involved in a rollover crash and break them down for you. We'll look at you, your vehicle, common rollover circumstances, the physical dynamics of vehicle operations, and the mechanics of vehicle operations. Then we'll explain what you need to do to maneuver safely out of a potential rollover situation. As the driver, you are responsible for your vehicle from the time you climb into the cab to answer a call until the time you return to the station. Your training, your experience, your physical conditioning, and your mental frame of mind all have an impact on how you handle your vehicle. Proper driver training is critical to knowing how to operate your vehicle safely. Unfortunately, most driver training programs don't go into a lot of detail about potential rollover situations. But if you drive a tanker or any emergency vehicle with a high center of gravity, you need to know advanced driving techniques, and you need to know how to use them so you can stay out of trouble when you're on the road. The physical and mental demands in this business are tough, so you better be able to meet those challenges. If you stay in shape and can keep a cool head when chaos is breaking out all around you, you're a good candidate to take the wheel of an emergency service vehicle. There's also a hidden factor you need to be aware of: the impact of adrenaline. You know yourself that when a call comes in, the adrenaline kicks on, and blaring sirens, flashing lights, and people yelling all drive that adrenaline higher. Do your best to keep your adrenaline under control so you don't overreact when you're driving and send your vehicle into a rollover. The best advice? Know yourself, know your strengths, and your limitations. Emergency vehicles are getting heavier and higher. Years ago, these types of vehicles would weigh in around 10 tons. Now they're topping off around 20 tons or more. Why the dramatic weight increase? To meet the demand to carry more equipment, more people, and in the case of pumpers and tankers, more water. Now, to carry more, we had to make emergency service vehicles bigger. But these vehicles can only be as wide as the traffic lanes they move through. So, since we couldn't go out, we had to go up. We used to build vehicles to a height of 8 feet. Now it's not unusual to see them at 10 feet, and aerial pieces are even a little more, 12 to 14 feet. Here's why height is significant. The higher the vehicle, the higher the center of gravity. The higher the center of gravity, the more unstable a vehicle is. The more unstable a vehicle is, the more difficult it is to control. Remember these concepts. We're going to come back to them later. The vehicle's suspension is also important in how a vehicle handles the road and how it carries weight. A weekly visual inspection of your vehicle will tell you if the suspension is intact and operational or not. This is possibly the most important part of your vehicle, your seat belt. Make sure you have it on before you pull out of the station. If you don't wear it, you could be putting yourself, your passengers, and others at risk if your vehicle rolls over. Know yourself. Know your vehicle, its height and weight characteristics, how it handles in both emergency and non-emergency situations, how it handles on highways and rural roads, and finally, wear a seatbelt. We can't emphasize that enough. Now let's take a look at this. What you're about to see is a tanker rollover. This tanker, filled with thousands of gallons of water, is traveling down a straight road and heads into a curve. The posted speed is 45 miles per hour, about the speed the driver is doing. But as you'll see, it's too fast for the road conditions. As the vehicle enters the curve, the driver slows down, causing the water load inside to shift to the front of the vehicle. At the same time, the vehicle leaves the pavement and the tires drop off a few inches onto the soft shoulder. The driver immediately yanks the wheel hard to the left to get the tanker back on the road. But the tire change from a hard surface to a soft surface, the weight load shifting inside the tanker, and the driver's excessive relative speed caused the vehicle to shoot across the road and go off the left shoulder. When the driver frantically overcorrects back to the right, the unstable vehicle rolls over and ends up on its side. Now we'll tell you about each of the factors involved in a typical rollover crash. Later, we'll come back to this scenario and show you how it could have been prevented. In this segment, we're going to take a look at the 3 most common reasons rollovers occur. They are traveling at an excessive relative speed into a corner or a curve. Excessive relative speed is the vehicle speed measured at any miles per hour which is considered unsafe in relationship to the operating environment, road conditions, or the vehicle. The other factors are soft shoulder drop-off and uneven surface drop-off and improper recovery. To help explain these rollover conditions, we're going to turn to an expert. His name is Herb Kaufman. Herb is a former fire chief who now works as a Pennsylvania certified state instructor. He's also an automotive and aerospace engineer for the Society of Automotive Engineers, or SAE International.
We may, as drivers, be looking too far down the road. We may not be anticipating the curvature of the road. It may be a road that we aren't familiar with. And so we enter the curve at a much higher speed than we safely should. That causes the driver to oversteer, maybe overcorrect as you enter the curve, and overcorrecting for it could cause the vehicle to swerve and roll over. One of the situations that creates that rollover scenario is dropping off on the right shoulder, typically the soft shoulder of the road. With so many of our departments running in undeveloped areas of the country, the berms of the roads are not properly maintained and may have no pavement at all. So dropping from a paved highway onto a soft shoulder at highway speeds creates a very dangerous situation. Once the vehicle has dropped off the edge of the road, then the driver may even jerk the wheel to the left to pull the vehicle back on the road quickly, throwing it into a situation where it swerves across the road and may not roll over until it actually crosses the highway and drops off the berm on the other side, or hits a curb, or runs into oncoming traffic. But that instantaneous quick reaction by the driver to overcorrect will cause the vehicle, again, throw it out of control.
At the beginning of this presentation, we told you that a majority of rollover crashes are caused by driver error. Those errors occur because many drivers don't understand the laws of physical science and how those laws affect how a vehicle will handle under certain conditions. So let's review some of those physical dynamics that you probably learned in your sophomore physics class. The law of inertia states that an object in motion will stay in motion along a straight line unless it is acted upon by an unbalanced force. Momentum refers to the weight of the object in motion combined with the speed or velocity at which it is traveling. The height, weight, and width of your vehicle combined with your speed will produce a momentum that you must be able to keep under control when you're out on the road. The center of gravity on a vehicle is the place measured from the ground up where the weight will be equally balanced. Okay, now that you have a grasp on some of the physical laws that control moving objects, we're going to apply those laws to your vehicle and tell you how it will react in specific conditions. We'll start with one that shouldn't surprise you: speed, driving too fast. NIOSH and the USFA have both determined in different studies that excessive relative speed is a common factor in most rollover crashes. The key word here is relative, which we told you a few minutes ago means your speed in relationship to your environment or road conditions or your vehicle. Friction, for our purposes, refers to the tire patch or the footprint of the tire to the road. The footprint of one tire is about the size of an 8.5 by 11-inch piece of paper. If you drive a single-axle vehicle, you have only 6 tire footprints keeping your vehicle on the road at all times. So you can imagine, for example, if you drop off onto a soft shoulder at an excessive relative rate of speed, that friction will be severely compromised. Then, when you try to steer back onto the hard road surface, you'll face a tough challenge. To compensate for the difference in height between the road surface and the soft shoulder, you'll need to apply a greater angle of steering to overcome the resistance of the road surface against the tires of your vehicle. The last category related to mechanics that we want to talk about involves what's called the liquid slosh effect. If you drive an emergency vehicle that carries water, you need to know this.
The solid loads tend to be steady, more controllable. You can hold them in place. Liquid loads move about as you're going down the highway. They move side to side as you're going through curves. They'll move front to back as you're accelerating and braking. So you have this liquid in constant motion. We all have heard about baffling being installed inside tanks to minimize that water slosh, we call it, but it still occurs. Also, a dangerous situation in the load factor is the idea that you may only have a half a load of water in there. Ideally, a fire apparatus would either be totally full or it would be empty, but for some reason you may only have a half a load of water, and that slosh effect is dramatically increased by only half a load.
That slosh effect is going to shift the center of gravity in your vehicle. If you're traveling at an excessive relative rate of speed entering a curve, this weight transfer will make your vehicle roll and really impede your ability to keep your vehicle on the road. Bottom line, maintain a slow, steady, safe speed. It's true, there may be people injured on the call who need you urgently, but before you can help them, you need to arrive safely. Play it safe. Get the proper driver training on preventing a rollover. And when you're out on the road, slow down and wear a seatbelt. We want you to live to serve another day.